Hi guys, this is a calculus video, recovery video 6, and this recovery video corresponds to this technique. Can you use long division to rewrite the input? Okay, so here's the clues. The input of the integral is a polynomial over the polynomial. That's polynomial over a polynomial. Clue number 1. Clue number 2, the degree of the denominator is lower than the degree of the numerator. Sorry, I'm tired. Okay, so this is an indefinite integral, which means that the input is a function, but the output will be the antiderivative of the input. And when all is said and done, once we've taken the antiderivative, all of this stuff is going to be gone. Okay, so it's a polynomial over a polynomial. The degree of the numerator is 3. The degree of the denominator is 1. The degree means the highest power. So this is a candidate for using long division to rewrite the input. So long division, if you are shaky on long division, you should look at that YouTube video that I sent you a link to. It's not one of mine, but it has some nice long division examples. So I'm going to go off in a margin and do some polynomial long division. Okay, so x times what makes x to the third? X squared. So I put x squared up there. Then I multiply it back out. So I get x to the third minus 7x squared. Then I subtract. Those cancel. We get negative 2x squared. The 15x comes down. And we do it all over again with these. So x times what makes negative 2x? Negative 2x squared. Negative 2x squared. So negative 2x. Then we multiply that back out. So we got negative 2x squared plus 14x. Then we subtract that. Those cancel. That'll just be 1x. And then the 12 comes down. Minus 12 comes down. Okay. X times what makes x? Positive 1. So then we multiply that out and we get x minus 7, subtract it, and then those cancel and we get negative 5. Okay, so that is the remainder, okay? So that means that we could rewrite this input like this. So this is the indefinite integral, and then you write the answer that you get up there. So x squared minus 2x plus 1 minus, because it's a negative remainder, the remainder over x minus 7 dx. Okay, so guys, all of this we can use just power rule for. This part we're going to have to use something else for. But now I can split up this integral as x squared minus 2x plus 1 dx. And I'll just bring the minus out front. Minus the integral of 5 over x minus 7 dx. Okay. Now, for these are just a simple power rule, so I'll come back to that. This one actually, if you let f of x equal the denominator, then f prime of x is 1, okay? Well, guys, we can very easily get a 1 up here if we just move the 5 out front, okay? A 5 in the numerator, just a constant 5, it's like this whole fraction is being multiplied by 5, or 5 over 1. So I could just move that 5 out front and make that a 1. All right, and then I can use the f prime over f formula for that integral right there. So for this part, so now I am taking the antiderivative. Okay, I am taking the antiderivative, so all the integral stuff is disappearing now. I'm getting my final output. So this is 1/3 x to the third minus x squared plus x. Don't worry about the plus c. We'll put it at the very end. This minus 5 can just come down. Natural log of the absolute value of the denominator of the fraction plus c. Plus c, because the output is a whole family of functions all whose derivative is the input of the indefinite integral. So this c could be any constant, and the derivative of this, when you take the derivative, that would be 0, the derivative of that. So we'd end up with the original. So there's that, guys. Recovery video 6 that was. Alrighty, see you soon.